Hello, my name is Daniela Alvarado.
And I'm Alonso, and today we'll be talking about the chemistry of coffee.
We will be giving a brief overview of the information, introducing the topic, reporting findings, and giving final thoughts on the research.
We studied the chemical composition of coffee and its long-term effects on the human body and brain. Concepts such as neuromodulators and receptors are explored to determine the effects of caffeine intake, such as withdrawal symptoms. Finally, methods of decaffeination are discussed.
Coffee is composed of over 1,000 compounds. The main components in coffee are carbohydrates, lipids, amino acids, and many other biological compounds. However, the most important compound that mainly contributes to the feeling of alertness and awakeness coffee drinkers experience is caffeine. Caffeine is a central nervous system stimulant in the methylxanthine class, a unique class of drugs derived from the purine base xanthine. In Figure 1, the chart discusses a study on the chemical components of coffee done by a medical research group from the Netherlands called Elsevier. Their study effectively broke down the percentage that each compound shows up in different types of coffee. In this slide, I'll be going over the chemical properties of caffeine. Caffeine has molecular/covalent bonds. Its melting point is at 235 degrees Celsius, and its boiling point is at 178 degrees Celsius. Caffeine is a molecular solid, but it is soluble in water. Caffeine solutions in water are considered neutral. Caffeine has low conductivity, it's an odorless white powder, and it has a bitter taste. Caffeine's relationship with brain receptors has to do with how it binds to adenosine receptors in the neural membrane. Adenosine is a central nervous system neuromodulator that binds to specific receptors in the brain and signals the body to fall asleep. Caffeine acts as an adenosine receptor antagonist, which is a drug that binds to a receptor that doesn't activate it. So instead of signaling the body to fall asleep like adenosine does, caffeine counteracts the feeling of tiredness by secreting hormones that inhibit adenosine's effect and make coffee drinkers feel more awake and alert. In this slide on Figure 2, we compared the way that adenosine would normally bind to its receptor to how caffeine acts as a receptor antagonist, inhibiting adenosine's effect on the human brain and body. The third figure on the right points out the similarities between the chemical structures of caffeine and adenosine. These similarities allow for caffeine to bind to adenosine receptors, therefore inhibiting adenosine's effect on our bodies.
So, a common misconception about coffee is that it leads to addiction. This notion is incorrect due to the fact that the amount of dopamine signaling that happens when drinking coffee is not enough to cause an addiction, but merely a dependency on the drink. Dopamine is a chemical that controls a person's alertness and movement. This chemical is signaled when caffeine, a stimulant, enters the body. Other stimulants, such as methamphetamine and MDMA, do lead to addiction because the amount of dopamine signaled through these substances is much greater than through caffeine. Addiction can be defined as a lack of restraint when taking substances. Because of this definition, it's clear that a person who loves coffee can survive without it, but someone that is addicted to substances such as MDMA would have a harder time trying to get past those addictions. So as seen on Figure 4, an experiment proved that caffeine does have withdrawal symptoms. In the following case, 4 double-blind experiments, which is when the researcher and the participant isn't aware of who has the placebo, were conducted to analyze which withdrawal symptoms occur in correspondence to doses of caffeine. In the first experiment, there was no concrete proof that the magnitude of the symptoms were different when having 300 milligrams of caffeine in one sitting than having 300 throughout the day. In experiment 2, the severity of the range increased as the dosage went from 100 to 300 to 600 milligrams a day. Even the smallest dose of 100 milligrams caused symptoms. Experiment 3 showed that participants were kept at 300 milligrams per day and tested with a range of low doses like 150 milligrams a day. There was a substantial reduction when was needed to cause the symptoms. And lastly, the last experiment altered the exposure of caffeine and it changed the withdrawals to as little as 3 days after the last intake. So it takes very little amount of time to see these symptoms. And the symptoms that were recorded were headache, tiredness, alertness, and a poor mood. The long-term effects of coffee are important when we consider intaking so many doses of it every day. The negative effects of this coffee include trouble sleeping, also known as insomnia, irregular heart rate, frequent urination, increased blood sugar, nausea, anxiety. This drink also has multiple benefits, which include alertness, and it reduces the probability to have very health problems and diseases such as like oral cancers, stroke, type 2 diabetes, and Alzheimer's. Then we will discuss the decaffeination methods of coffee. So there are several ways to decaffeinate coffee. The first method is through carbon dioxide method, and it involves forcing carbon dioxide through coffee beans under 31 degrees Celsius and 73 atmospheric pressure. When CO2 enters the supercritical state, it dissolves most of the caffeine in the beans, and the CO2 is sprayed with water to remove the caffeine, and the water that's left over is filtered and isolated. And then the next method on the right shows where coffee beans are steamed, rinsed with methylene chloride, drained, and then steamed again to remove excess solvent.
These are the websites we used to find information on the chemistry of coffee and its findings. We hope you learned something new. Thank you.
Thank you.